We're going to begin our discussion of the powers of I in a very pragmatic way, looking more at how do I reduce these powers efficiently and effectively, not necessarily why do they reduce the way they do. So I'm going to start with four basic facts. I'm going to look at I to the first, I to the second, I to the third, and I to the fourth, and see what each of these quantities reduces down to. By the rules of redundancy, I to the first is just I. We've already seen that I to the second is -1. If I want to look at I to the third, all I have to do is multiply I to the first and I to the second. So multiply that -1 times the I, which gives me -I. And last but not least, I to the fourth, I could consider as I squared times I squared, which is -1 times -1, which gives me +1 for I to the fourth. Notice how everything reduces down to either plus or minus 1 or plus or minus I. Specifically, consider the fact that for my odd powers, I have an imaginary left in my problem. And for the even powers, when I reduce, it goes down to plus or minus 1, a purely real number. So these four here are going to form the four categories that any other power is going to reduce down into. So the question is, how do I put these other powers into those four categories? What I do is I look at the remainder when I divide by 4. What that will do is put any other number into one of these categories. Let me show you how. I only have 4 possibilities for my remainder. I could have a remainder of 1, I could have a remainder of 2, I could have a remainder of 3, or I could have a remainder of 0. There's no other option when I divide by 4 as to what my remainder can be. So if I have a remainder of 1, it's going to put it in the same category as I to the first, which is I. A remainder of 2 is going to put it in the same category as I to the second, which is -1. A remainder of 3 is going to put it in the same category as I to the third, which is -I. And a remainder of 0 is going to actually work the same as I to the fourth, which is +1. So this right here is the chart that I need to look at and consider in order to determine what any power of I reduces down to. So let's look at a couple examples. If I start out with something as simple as I to the 9th, all I really care about here is this exponent. Since it's odd, I know that it's either going to be I or -I. And now I need to consider what is the remainder when I take 9 and divide it by 4. And I get a remainder of 1 left over. 4 goes into 9 2 times with a remainder of 1. So that puts me into that category right there. So when I go down to reduce my answer, I know that my final answer is just going to be I. So I to the 9th is the same thing as I. It reduces down. If I take a slightly larger number, there's nothing really more difficult about it. Something like I to the 38th. Now in this case, I know that I'm in an even category. I'm either going to have a remainder of 2 or a remainder of 0. So I go ahead and divide 38 by 4 and realize that I get a remainder of 2. So that puts me squarely into that category. So when I reduce I to the 38th down, I get -1, a purely real number. There's nothing imaginary left with it. As the numbers get larger, it does not get any more difficult. I to the 60th, I consider 60. I know that 60 is even, so I know the answer will be plus or minus 1. When I find the remainder, my remainder is 0 because 4 goes into 60 evenly. So it puts me into that category right there. So when I reduce down, I just get the number 1. So I to the 60th power is the same thing as 1. And we can do absurdly large looking problems fairly easy this way. If I have something like I to the 5,847th, I look at that and I say, okay, if I divide by 4, what is my remainder going to be? And in this case, I'm going to have a remainder of 3. So remainder of 3 puts me into that category right there, which in effect gives me negative I as my answer. If you know any of the tricks to dividing by 4, you look at the last 2 numbers, and that'll tell you a lot about it, if it's divisible by 4 or not. So just to extend this slightly, stick some coefficients with the i's. If I had negative 4, I raised to the 398. I'm going to take this as 2 separate pieces. I'm going to leave the negative 4 right here, and I'm going to reduce the power on I first, because that's going to make my life a lot easier. So when I divide 398, I get a remainder of 2. A remainder of 2 means that I really have negative 4 times negative 1, which gives me positive 4 as my answer. If I take another example with 8i raised to the 55th power, again, leave the 8 here, do nothing with him until we've reduced the power on I. So this is going to be 8 times something. And if I look at the remainder, whenever I divide 55 by 4, I get a remainder of 3. So that means that this whole quantity here is really negative I, or negative 1 times I. So when I go to multiply, I get negative 8i as my final answer. Reducing the powers on I is essential whenever we have any problem where there are powers above 1. So what this does with the powers of I is it allows us to go back and redo all the multiplication and addition we did before, but now to introduce a whole lot of big variables and big exponents everywhere.